All right, it's time for us to get started already.
Yeah, I made my account, but I didn't ask for any like the low votes.
It's Monday. How are we all doing? Tired. Sounds about right. So I just published our new assignment. So assignment is up. We should be ready to at least get started with it. I kind of combined two smaller assignments with it. So they're the hash table, but there's no coding associated with hashing. It's all just on paper. And then you'll be implementing merge sort and quick sort that we go over the next couple of days. But with no frills or twists, you're just implementing them for our linked lists. You'll add them in extra classes in under your sort. So hopefully this shouldn't be too bad. I'm putting it Friday for the moment. I usually like things due on Wednesdays, but with 3 weeks left, I figure this leaves us the best path to the end of the quarter. I know, it's crazy. So, end of last class, I guess let's talk the last 3 weeks. We're talking about a schedule. We're either going to have an exam at the end of week 9, the end of week 10. It'll depend on a little bit the pace that we cover the remaining material at. My plan is to spend most of that last week talking about interviewing and internship and job preparation. I don't write exam questions over that material. So if we get there plenty early, we can take an exam end of week 9 and just have a stress-free week 10. I know that probably most of your other classes are not doing a stress-free week 10. So where it's possible, I like to try to free it up a little bit. But we'll see. I won't put pressure on the class to force that to happen. We'll see what happens. But that is my plan at the moment. One or the other, depending on the pace at which we cover the remaining material in the class. We're talking about advanced sorts, then we'll go into binary search trees, and I want to spend a little bit of time on graphs to get you prepared a little bit for algorithms. I don't know exactly when you'll be taking algorithms, but that first exam in that course usually has an average in the 40s, maybe the 50s. You had curves for it, but I want to try to ease you into that material a little bit, so you're not seeing it for the first time right ahead of that evil first exam. All right. That was a real transition. That was a real introduction. I'm just diving right into content. End of last week, we were covering merge sort. We were talking about how we could improve on our sorting times if we are allowed to use recursion, or if we think to use recursion. So we talked about the base process of merge sort. It's really just this 3-step process. So the process we're going to go into, step 1, we have an array we need to sort. We're going to split it in half. There's going to be a left half and a right half. We are then going to recursively call merge sort on the left half and the right half. When control returns to us from that process, we will have a left half and a right half that are sorted. And the only thing that is left to do is to do this process that we're going to call merge, where we take 2 sorted arrays and we collect them into 1 sorted array. So the way we're going to do that, we have counting pointers at each index 0. Check whichever one's less. If whichever one is less, we're going to copy that into the first position of the new sorted array and bump up that associated counter. Then we're going to compare the 2 values at the 2 counters and say which one is less. Copy that into index 1, bump up the associated pointer, continue that process until we've copied over everything and we have 1 merged sorted array. And it turns out that entire process solves the problem. We don't need to worry about the magic that happens at lower levels because an array of size 1 is already sorted. And an array of size 2 can be split into a left and a right of size 1. So that entire process solves any sort. And it's pretty cool to see. This is probably my favorite sort, and it's the one that Java uses by default. Although Java is one of the few languages that do it. The next one we will cover actually is the basic implementation of most languages sorts. So let's go through an example. Since these were all refilled, what color do we want? Except for I think red. Red is not refilled, but other than that, looks like it was red. Wonder if the orange got the red. You say it shouldn't have. We'll see. Orange feels full. Preferred color? We're gonna do blue. It's been a while, right? This gets used first a lot. Probably says something about it. So we're going to do an example. We are going to do an example of size 8, because I feel like that is an appropriate size. Let me write these up here. All right, as always with sorts, I need numbers. More,
17,
more, 6, 4,
2,
yes, more,
38,
more,
9,
2 more,
21,
and
14.
excellent. Have a duplicate in there because that'll work. Okay, so we are going to assume that we make an instance of merge sort. Let's just call this something like merge sort 8. That is going to be the instance of our recursive function that is handling this. So what is the first step of merge sort? Split it in half. So we're going to say, here is a left half, and here is a right half. We're going to kind of break it apart, and we're going to first call merge sort on the left half. We're going to wait for it to return, and we'll call merge sort on the right half. So here is merge sort on the left half. We have an array with 14, 17, 6, and 2. This is going to be a call to what I'm just going to call merge sort of 4, size 4. This is just another stack frame. It should be the same size as the stack frame, but I'm kind of trying to draw it the size of the array so you get a sense of the amount of work that we're being asked to do. So we leave this stack frame and we enter this stack frame. This stack frame is another instance of merge sort. So what is the first step of merge sort? Split it in half. So that's what we're going to do. We have a halfway point here. We're going to call this L, we're going to call this R, and we're going to split this into a left half and a right half. We first call merge sort on the left half. So this is going to leave this stack frame and go make a new stack frame. This stack frame is merge sort 2. This is just 14 and 17. Are we in a base case yet? No, there's nothing of size 1, so we have to break it apart. What is the first step of merge sort? Split it in half. So we're going to find the halfway point here. We're going to split left and right. We have an array of size 1, 14. This is our merge sort of 1. I'm not really going to write it because we're going to return from it immediately. Is it a base case? Yes, it's already sorted. So we are just going to kind of leave this here. We're going to return it as one of the 2 elements that we're going to merge, but we need that back. Going to be the sorted left for this. I kind of forgot to write my left and right here. We're going to do exactly the same thing right. We're going to make a new merge sort of size 1 instance, and we're going to see that we are in a base case. 17 is returned. We have a left and a right. So now we need to, from this case, we need to go through the merge procedure. So to go through the merge procedure, we're going to put a pointer here and a pointer here. And we're going to say, which one of these is less? The 14 is, so that's what's going to go here. It's already here. Then we bump up this pointer, we see that it's out of bounds. We're just going to go in a loop and we're going to copy everything that is left in this array into the rest of it. So we get a fully sorted array with no changes of size 2 here. So we've gone through the merge procedure. After we do that, we're going to return back to this form. When we do this, we've successfully called merge sort on the left side, so now we need to call merge sort on the right side. So we're going to take the right side and we're going to break it apart. Probably write these in the box. 6, 2, this is the L and the R, we break it apart. We do exactly the same thing, we have a 6. We have a 2, both of those are base cases, so we come back to this position and we're now going to ask which of these is least. And we see that the 2 is, so we're going to write the 2 here. You see that we have the 6 here as next, this would be out of bounds, so we just copy over the 6. So we have a merged right half of this array. Since this process is done, we now return back to this scope. With this scope, what we just finished was the right side of this. So we have 2 sorted arrays ready to be merged. So from this position, we're going to start a pointer here and a pointer here. Once we know they are both sorted, we can now ask which is less, 14 or 2? 2, so we're going to write in here 2. We bump up this pointer since it came from our right, which is less, 14 or 6? 6, so we're going to write 6 right here. We bump this up, oh no, it's out of bounds. This means we can just go in a loop for the size of this array and we can just copy it over. So as we are here, we'll copy over the 14. Bumping up to here, we'll copy over the 17. And we see that we are now done and we've made a sorted array. But now we have to return to the scope of the merge sort of size 8. We have a wonderful left sorted array, but now we have to go do the same thing for the right side. So we're going to make a new instance of merge sort size 4 with 38, 9, -21, and 14. We're going to break it into a left and a right. We're going to do that. We have a 38 and a 9 here. This gets broken apart. We probably do this the same. We have a 38, we have a 9. Now that we're done with the base cases, we move back. We put pointers here and here. We see that the 9 is less than the 38, so that should go here. Now that we have merged this together, we go back here. We've done the left half, and now we have to do the right half. A little more space for these negative numbers that you had me write. Yeah, we're again able to see that -21 is less than 14. So we copy those over, we see that this is now correct. We can put these pointers here as we try to merge these back together. In this side, we see that -21 comes first. Then 9, then 14, then 38. So after this process, that's the state of the array. We come back to the merge sort of 8, and now we have to go through the big merge. So we put pointer here, pointer here. We can now determine which one is less, 2 or -21. -21, that'll be what's put in index 0. Bump it up. What's less, 2 or 9? It is 2. Bump it up. What is less, 6 or 9? 6. Hey, it's even already in the right place. Bump it up. 14 or 9? That one's 9. Bump it up. What is less, 14 or 14? Doesn't matter. We're going to bias ourselves and say that it comes from the left, if possible. What is less, 17 or 14? 14. Bump that up. 17 or 38. 17. This is now out of bounds, so we can just loop through and put everything that remains here back into the array, and we end up with our sorted array. Does this feel like more or less work than every array that we've, or every sorting that we've seen so far? It's annoying that it looks like it's more work when you break it down like this. It scales so much better. And the reason that it scales so much better is that we're only adding an extra row to this logic every time the array size doubles. So it would take an array size of 16 to add one more layer to this, an array size of 32 to add one more layer, an array size of 64 to add one more layer. So it actually scales quite efficiently in terms of the total amount of work that has to be done. Yeah.
What happens if it's odd and not even?
Yeah, so then in a left and a right, one of those will be a base case and one of them will not be.
Okay.
You just have to be consistent about choosing when that is the case, where is the middle? Is the middle, if you have a middle of 3, is it between element 0 and 1, or is it between element 1 and 2? Does not matter which you pick, again, as long as you're consistent. Questions about this concept, this logic? Let's see if we can implement this. I think that's the next thing on my plan, is to have you break into groups and implement. Yes, in fact, it is. So I'm just gonna leave this up here for the moment. But let's take a few minutes and see if we can make this work just for arrays. And we're going to making this work for linked lists or even array lists. Unless you want to use an array list, that's fine too. But choose whatever you would like to that you think will be easiest. And we will come together in a few minutes and implement it ourselves. Yeah.
Tomorrow or Wednesday, not which day. Was my staff able to estimate on the class? Sure. Figure that out. Yes.
Yeah, I think you mentioned that before.
Far better at that. I was with my sister first. Yes.
Yeah,
Especially when I'm arguing.
I was the first in my family to get a CS degree. Come from a family. Very different.
And not the first gen. Like how the experience.
Yeah, it's pretty true for my parents too, like. My dad was in the drama, but in theater stage design. Yeah, my parents got in drama in college. And my mom went on to get a master's in English and then use it a ton.
My dad's sister is masters in international affairs in English. So he is. And so I was much and she has her youngest is finally in high school right now. Her middle just started. So weird seeing them grow up because they're all just only my sister. So like you're like neither of our parents. Large margin. So I can come on. She takes a stop. Oh,
So it all comes together. The main reason for that one is that it appears on the truth. But it does also.
Yeah, so I saw them. It's very good.
Yeah.
Recess. Yeah.
See.
Yeah, no.
Well, if you type it in and it's not.
So unexpensive. I still. Actually.
Shoot.
Yeah.
Yeah.
I'm sure you can sign with me,
No, you don't want us to do anything. How are people doing with this? Are we able to get started?
Oh, it's a lot there.
It's probably slightly easier with the right list, but we're gonna do it a fun way. Regular.
Working on words.
Or no, because there will be a little bit of a change, but that's. You know what I'm saying? Mistakes. It's like you encourage on. And the reason I'm gonna implement it this way is to make it easier. For think of thoughts of this.
Oh, no,
That's.
Democracy, human rights, and peace,
I did not look.
no, but are you a big history person?
I have a studies major, so pretty much we just studying studies. Joking, I'm all.
Yeah.
And then we have much we think about. I'm really much depends on what's entirely different curriculum and stuff.
That's pretty cool.
Yes.
I know. There's not very few. Because a lot of my family's here and I actually do well. And then I know ASL. So that's good. You thought my sister's deaf in one person. Yeah.
Yeah, like.
I was kind of jealous of those teachers on her hearing aid. She can like.
That's one.
She's so deaf.
Or yeah.
It's just like a.
Oh, you have.
Where-
Oh, yeah. Very popular.
It's so funny. It's like you.
Yeah, this statement of the starting I has.
She learns something new every day. This process eventually creates merge or
Like, you didn't go fully on call. One of those sounds bad, and we started there, it's like building something. I don't know which one's the actual one that's popular, and say, oh, what did you say? They was less than the music. Wait, with my phone. Yeah, so. The new time. It's not the name. It's all the. I feel from the version.
I have a dining table in my house, but it's more like a craft table. Because it's really just like simple or. Like, I in my office, what's the time? It's like.
I my bedroom.
So that one we just want to do right at the bottom, but.
But we got this really cool compact. Where the side on there. Like this.
Well, that's not sure.
So. And all there's no one.
Yeah, basically, it's too much of a price. It's a red.
On the right side, we can merge or.
Like labs. Three labs.
That's literally why I'm here.
Next, open records or hospitals are done.
Oh, we're on local studies.
Way. Maybe that's more. And I'm a student, so the left side, I'm 2 years old.
Yeah.
That's why.
The mid is gonna be, yeah, an index here, 5/2 is gonna be 2. So, yeah, the left side is gonna be something of size 2. Which would be old indices 0 and 1, and then right would be 2, 3, and 4. We're biasing it, the left side is shorter and it's off. It's the same. These are the things. What's the easy syntax to copy these over? We can, there's an easy way and a hard way. I suppose I should probably erase the board, because there's a lot here. Okay. So I first checked for a base case. Because we're gonna be using this size of the array pretty frequently in this, I'm just storing it off, and that way we're not querying arrays length over and over and over again. And N just is a little bit shorter than ARR.length. Then I'm breaking it in half, into the left half and the right half. The way that I'm doing this is figuring out, okay, we know how long the array is. So if we use integer division, we can figure out how long half the array is. N/2 is going to bias toward now the left side being smaller than the right side. So we have an array of size 5. 5/2 integer division is 2. So we're making a left side that is size 2 and a right side that is size 3.
Now, why do you have the right side as n minus mid and then the left side mid? Like, does it matter, like, if you switch them, or does it?
It would depend on the only thing that changes is the bias of where the longer array is. So if we did it the exact opposite way, then we, in a case of 5, the left would be 3 and the right would be size 2. As opposed to the way I have it right now, left is size 2, right is size 3. Just, again, as long as I'm consistent, I can do it either way.
Is it important to store the array length?
No, not necessarily. It just, it'll save ARR.length from showing up all over in this program. So that would be R.length, R.length, R.length. And I just find it a little bit easier to have something that's a little bit shorter there, but again, wouldn't be wrong. What's next? What do we want to do next? Yeah, we need to copy things over. So what's the easy way and the hard way to do that? Maybe we'll start with the hard way. That's the intuitive do-it-yourself way.
Manually loop through each app and assign.
Manually loop through each app. Yep, we could absolutely do that. What's the easy way? Anyone know the syntax for the easy way?
Isn't that like an array copy method or?
Arrays.copy would be the easy way to do it. Let's write it out because no arrays.copy exists in our linked list, so it'd be useful to see it, but maybe we should just do it and then replace it. So arrays.copy gives us, that's copy. So copies the specified array, truncated or padding with false, this is what boolean. We want to make sure that we're looking at the integer version of this. Just if we're gonna read the. So copies the specified array, padding with the default zeros. For any indices that are valid in the copy but not the original, the copy will get to 0. Such indices will exist. So you just take the array to be copied and the length of the copy to be returned. So how many elements do we want to copy? Returns a copy of the original array, truncated or padded to obtain the specified length. So how would we do it? What's the call?
When you wanna call it the old and
Yeah, we're gonna take the old and a length, and it returns that, so we could say left equals arrays.copy of, and we will have to import arrays to do this. Arrays.copy of takes the original, and it takes a length. Then we would say this is doing exactly what we would be implementing ourselves. So this is the easy way to do it. So I'm just gonna leave these commented out for the moment. And we'll actually go through and write the loop, because if you're doing this on a linked list, which is what your homework will be having you do, there's nothing quite this nice for this. We could just write a loop to do it. What would that loop look like for the left half? We know how many elements it's going to be, so we should write this as a for loop. Yeah.
I0, I less than mid, I plus plus. And then we assign left at I equal to R and I.
So that's our for loop. Outer, we know exactly how many of these we're gonna do. From 0 up to, but not including mid, will be the length of the new left. So we can say left of I, we're gonna directly copy over is ARR of I. That will loop through ARR at that same index and copy it over. The next one is a little bit slightly more challenging. What do we want to do for the right half? How do we make sure that those indices line up? Where should we start I out at?
Like at the middle.
Yeah, let's start out at mid. Since this was less than mid, the next element that we want to look at in the old one is going to be mid. Great. What should we set our termination condition to be? The end. What are the guts of this for loop? What is that going to look like?
It's just the same as the first one, but right instead of left.
Yep. So right of I, since we already have the associated index for that. Do we want ARR of I?
Is that not gonna try assigning the index at like 6 or something, or like 3?
Yeah, that would be. So if we keep this exactly as such. We're gonna get an index out of bounds exception because we're trying to fill outside of the bounds of right. So something needs to change about this. What?
Oh, would be like,
You need to subtract something. Yeah, I minus mid will get us there because it was that offset that we're using. If we shift everything back by mid, we're gonna start filling in right, starting at index 0. And we'll be looking at the associated index that we care about in ARR.
Why can't this be crossed with a single filter?
It could be. You just need some kind of,
I mean, it's just an offset, right, technically. It's
Yeah.
offset and you can put it first.
yeah, you just have to have some kind of if statement inside of the for loop to look at, like depending on whether we are less than mid or greater than or equal to mid.
you explain this, or at least I understand the first one, I don't really understand.
Yeah, so we have.
Because it's starting to run. The operations.
Yeah.
Straight back arch.
So this is index 0, this is index mid. And this is index 0 and index 0. If we were to look at this and think about the associated offset, if we're copying over from ARR into left, there's a direct correlation between its position. It's an identity relationship between the position in ARR and the position in left. So 0 maps to 0, 1 maps to 1, 2 maps to 2, 3 maps to 3, etc. But when we want to start filling in right, there's an offset here between index mid and index 0. We want to start filling in here at index 0. We want to be looking at index mid here. So our counting variable is going to start at mid, which is why we say we're going to map ARR of I, which starts out at that mid, but to scale it back into the associated position in right, we have to subtract this offset, which is mid. So right of I starting out at mid minus mid gets us back to 0. And then as we move away from mid by some amount, we'll be moving away from 0 by that same amount. Questions on the why? Right. This should do it for us. So far. What's next? We look back at our outline of what we need to do in this method. We've now broken into a left half and a right half. We have a left array and a right array. What do we do next?
You have to call it, so.
We do. This is a recursive method, so we need to call itself, recurse. We can call merge sort on the left half. This will go through and do exactly this thing where now ARR was just a left half from the prior. We can then merge sort the right half. This will go and do exactly the same thing with the right half. Now we need to merge them. And I actually wrote a separate merge function because I think splitting up that logic will be good for us. Merge takes 3 parameters, the array, a left and a right. So let's pass it in like that. The goal of this call will be to produce the sorted array from left and right. And at this point, we know that both left and right are sorted. Note that all of these are void because we are passing everything by reference. So that's just something we have to be a little bit careful of, is knowing that any change we make permanently affects that memory. How do we want to merge? We can do this iteratively, we don't have to do it recursively. This one's a little bit harder, especially thinking about it iteratively as a loop.
Would you say like for inside with 0 while I is less than, or like R root dot length?
Yeah,
Because we want to start filling in stuff in there.
yeah, so we're gonna go into a loop for sure. What variables are we gonna need? We said we need pointers into each one of these arrays, or reference variables that point at indices that are gonna tell us where we are in each of these arrays. So I'm gonna call this cur left. Cur right. And cur ARR. And in fact, I should probably set all of these to 0 because that is where we're gonna start out. All right, so we have 3 nice counting variables, all starting out at 0 since we're at position 0 in the resulting array and in the sorted other arrays. So we can now go into a loop. We do want to continue to fill all of ARR, but I'm going to hesitate to make this a for loop. And the reason is we can get in a position where we're looking out of bounds in left and right. If we move past the end of one of them, we're still filling in positions, but from the other array, and we don't want to check that array out of bounds. So I'm going to say, I'm going to write this as a while loop that will continue as long as all 3 of these are in bounds. As soon as one of them is out of bounds, then there's a separate check that we need to do. So we just say while cur left is less than left dot length and cur right is less than right dot length. I think that's all we need. There's no reason the other would fall out of bounds. So we can now start copying. So while these are both true, we now need to figure out, using some kind of condition, whether the left at that index is smaller or the right at that index is smaller. We know they're both in bounds because of the while. So we can say if left at cur left, let's say is less than, and we'll even break the tie this way, less than or equal to right at cur right. What do we know? What can we say?
So you set array is 0, or set array,
Yeah, we can
set array.
write to ARR at cur ARR to be, since we know that left is smaller, we want to pull from left. Make sense? Any questions on that?
Yes, are you can you explain like what happened there?
Yeah. Yeah, so we're doing the merge procedure, which means that we have a sorted left half and a sorted right half, and we're trying to merge them together into one sorted array. So to fill out this first position, we just need to look at this position and figure out which one is less. So we're saying while we're still in bounds here, well, we're not out of bounds here and we're not out of bounds here. If this element is smaller than this element, then we want to copy this element into here. Because one of these is going to be the smallest in the entire array. The question is just which one is it? We know that both of these are sorted, so the smallest either has to be the leftmost element in left or the leftmost element in right. One more thing for us to do in this if statement, what is it? Yeah, we need to bump up our cur left. This will say, if it came from here, we need to bump this up now to be looking at the next element. Because this filled there. So what goes in the next position would be either here or here. The other option is if this is not true, we need to write an else. If this is not true, then we go right is smaller, so we can say. This will be a nice little loop that just runs and runs and runs and runs until the first of these two is out of bounds. Either left or right is out of bounds. And we will have filled all the way up to this, and that is great. I should be, shouldn't I?
No, you can do that at the end of L.
Yeah, after here. Great catch. That is absolutely true. We're gonna bump that up regardless of which one of these we do. Yeah, great point. Once we're done with this, it might seem like we need to figure out which one of these to do. But it is just as easy to write the separate whiles rather than write an if that surrounds both of them. So we'll come back first thing tomorrow and finish this off, and start talking about quicksort. But we are almost there. This is almost done. We are just a couple lines away from finishing this off. I have office hours starting now. If you need it. There's a new assignment for you to work on. Have fun with that. It's 80% on paper, 20%. The grading is 60% on paper.